Hey everybody, it's Mr. Brew from Infinity the Math Institute. Welcome. I'm glad you guys could join us. We had such a good time the first week that it definitely looks like this is going to be a regular thing, especially because of the feedback we got from you guys. We spent the week and we got a couple of really good questions that we're going to go over today. Today is going to be a little bit of higher level math. We're going to be looking at some Algebra 2, pre-calculus, kind of the same thing. We have a great calculus question regarding limits, and then we also have a great middle school question talking about introduction to decimals and how to do rounding. Obviously, as the demand gets higher and higher, we might just split this up into an elementary day, a middle school day, and high school day, so that way the fifth graders aren't sitting here during my calculus assignments. But the number one best thing is you get to see a way that Infinity teaches stuff, the way we really get to the foundational aspects of each question. So when I show you how to do your homework question, you won't only have the answer to that question, but you're going to have a blueprint to doing other questions. And I'm also going to give you the background information. So if they ask a question a different way, or if they ask a different question on the same topic, you're going to have the tools to slay. All right, so we're going to be getting ready started here in about 30 seconds as the crowd builds up on both YouTube and Facebook. So I want to thank you guys very much. Please, if you haven't subscribed to our YouTube yet, do that. It helps us, and same with the Facebook Infinity page. I think we have like 900 people on our Facebook page, and once we get to 1,000, we get some perks. All the same thing with YouTube. If we get some 100 subscribers or something, we get some perks. So if you don't love my math lessons, but you love us and you want to support us, please throw us a subscribe and a like and tell somebody who could really use our service about us. All right, so let's get started. Our first question, obviously, we are worldwide, so our first question is coming all the way from Mississippi. Jacob, he's a 10th grader in Ocean Springs High School, again in Mississippi. He's an Algebra 2 student, and he's been working on polynomial long division, synthetic division, graphing polynomials, and obviously this is going to lead to all kinds of things such as the rational roots theorem, Dakarte's rule of signs, as well as a few other things. Let's see what comes up as I go through the problem and let you know what I see when I look at the problem. So his problem, the question, and make sure you guys always read the question, because half the time you guys answer something and you don't realize that you solved something, but you didn't actually answer the question. So it says completely factor and find all zeros for each polynomial. Zeros is another word for roots. Roots is another word for x-intercepts. X-intercepts is the value of x when y equals 0. Very important. So what they're actually asking is if you had this function f of x or y, you could call it either one, is equal to x to the third plus 4x squared plus 5x plus 2. All right, so first thing you should notice right away is the end behavior. All right, I don't like my equal sign, so let me just write that a little bit neater. All right, and when you're talking about end behavior, you need to look at two things. You need to look at the degree of the polynomial. The degree of the polynomial is equal to the largest exponent. So the degree of this polynomial would be 3. You got to look at the degree of the polynomial and the polarity of the leading coefficient. Polarity simply refers to positive or negative. The leading coefficient would be the term with the biggest exponent. What is the number in front of it? The number in front of it is the coefficient. In this case, it would be 1. But that doesn't even matter. All that matters is that it's positive. If the leading coefficient is positive and the degree is even, you're actually going to consider that just like you would consider the parent graph y equals x squared, which looks like a parabola going up. That's a positive leading coefficient and an even exponent. Therefore, the end behavior will be up to the left and up to the right. Also, immediately when I see this function, I see that the y-intercept is 2. Just like I told you the roots or the x-intercepts was the value of x when y equals 0, the y-intercept is the value of y when x equals 0. And obviously all those terms are 0 if x is 0, so y equals 2. So right away I can already start graphing, or at least get an idea of where I'm going to go with this graph. Let's just go over here. We'll sketch the graph because it's so much fun. All right, I know the y-intercept is 2, so I'll call that a 2. And I'm just going to sketch this because I know my end behavior is going to go up and up. So I already have an idea of what my equation is going to look like. It's a third-degree polynomial. The fundamental theorem of algebra states that the degree of a polynomial is equal to the number of complex roots. So, when they say complex, they're saying that it could be imaginary or it could be real. But nonetheless, it's going to have 3 roots. Real roots will actually cross the x-axis. That's what makes them real. They actually cross the x-axis. Imaginary roots will not. So I know I have 3 roots, and they could be real or complex. And that's very important too. So that means the curve will have 2 bends. If it's a degree 3 polynomial, oh my gosh. Guys, you see, I got to set up my chat because I know Julius would have corrected me right here. This is an odd degree, so I shouldn't be using x squared. I'm so sorry, guys. I should be considering it more of an x cubed with an odd and a positive coefficient. And we all know x cubed looks like this. So my end behavior is going to be down to the left and up to the right. So when I sketch that graph, I'm going to have that intercept still at 2, but I'm going to sketch the end behavior like that, which is going to kind of simulate what's going to end up happening. I also know it's a degree 3, so I have at most 2 humps. So it's going to look something like 1, 2. See these 2 humps? That's 1 less than the degree. All right? But that's all I have as of right now. Now I could look at there's some tricks that you guys get when you work on these things. One of those tricks is called Dakarte's rule of signs. I think last week I told you a little bit about René Descartes. He was a French mathematician. He came up with the Cartesian plane, but he also came up with a lot of great number stuff, mathematical stuff. But besides all that, he was one of the world's greatest philosophers. And, you know, some of these mathematicians of the old days really helped us understand how the human brain works and thinks. It's all logic. Math is essential in every single aspect. All right, so Descartes' rule of signs. If this is f of x, I just got to know what my polarities are. So the polarities of f of x are positive, 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 positive. The number of sign changes in f of x is equal to the maximum number of positive roots. How many times does a sign change? Well, positive to positive is not a sign change. Positive to positive is not a sign change. And positive to positive is not a sign change. That means there is 0 sign changes. Therefore, there are no or 0 positive real roots. So now if I go back to my graph here, I know this end behavior isn't actually going to be there. I'm going to have no positive real roots here. So actually from this y-intercept, it's going to be going straight up from there. Then I can take a look at f of negative x. Now, if I have negative x cubed, that will be negative, because a negative times a negative times a negative is a negative. Negative x squared is positive, because negative x times negative x is positive x squared. So this will remain positive. Positive 5 times negative x is negative 5x, so that will be negative. And the constant, it doesn't matter what the variable is, so it's going to be positive. So here I could see I have 1, 2, 3 sign changes. So that means I have a maximum of 3. So it would be 3 or 1, because they come in pairs. So I'm always going to be able to, when 3 is the maximum, I'm going to have 3 or 1. When 2 is the maximum, I'm going to have 2 or 0. When 4 is the maximum, I could have 4 or 2 or 0, because they come in pairs. If I had 5, right, I could have 5, 3, or 1. In this case, there's 3 sign changes, so that means I have 3 or 1 negative real roots. And what does that look like? That's very simple, guys, and that shouldn't scare you. If I had 3, 1, 2, 3. If I had 3 negative real roots, that would look like 1, 2, 3. You see, I touched the x-axis 1, 2, 3 times. If I only had 1 negative real root, it's going to be because the other one is imaginary. So it's actually going to look something like this. So I have those 2 humps, but I'm not actually touching the x-axis. That's the only difference between real and imaginary roots. The real roots touch the x-axis, the imaginary roots don't. But let's get even more precise. You may have heard of the rational roots theorem. Let me write that somewhere else to make sure, because this is an important one. All these other tricks that I've shown you so far are tricks that will help you out, and they may ask you specific questions about that on, say, an AP exam or a final exam to make sure you understand the theories behind it. But a lot of them are like common sense theories. This rational roots theorem is huge. So we're going to go over this in detail. The rational roots theorem states, hypothetically speaking, let's say we'll let P equal all the factors of the constant. So in this case, it would be all the factors of 2. Let Q equal all of the factors of the leading coefficient. Again, that's going to be the coefficient in front of the variable with the highest exponent. In this case, it would be 1. There's an imaginary 1 there if you don't see a number. So, all the factors of P, or the constant, would be positive negative 1 and positive negative 2. All of the factors of Q, or all of the factors of the leading coefficient, rather, are simply positive negative 1. And that's it. And the rational roots theorem states that given these numbers, all the rational roots, that doesn't mean all the real roots. Again, we go over number classification a lot, because when you get into these theorems and they start talking about rational numbers, complex numbers, real numbers, you have to know what they're referring to in each context. In this case, all the rational roots, which means numbers that can be expressed as a fraction, will be in the set of P over Q. So in our example right here, that entire set, everything P over Q, Q is simply 1. So in this case, I'm going to have no fractions. I don't even need the Q. It's simply going to be all the factors of P. And all the factors of P are negative 2, negative 1, 1, and 2. Those are all my possible answers. So what I'm going to do with that is I'm going to do synthetic division to see if I have a rational root. Now all we're doing, just like if you want to know if 7 divides 1,234, you stick 7 in and you try to divide it. If the remainder when you were done was 0, you know that 7 is a factor. And if there was a remainder, you would know that 7 is not a factor. So let's give it a shot. We'll do some synthetic division because it's a lot quicker than polynomial long division. I'm going to try the number 1. I just guess a middle number, and you'll see why later. I do 1. I do my synthetic division. My coefficients are 1, 4, 5, and 2. Bring the 1 down. Let me change color so you see my work. Bring the 1 down. 1 times 1 is 1. 1 plus 4 is 5. 1 times 5 is 5. 5 plus 5 is 10. 1 times 10 is 10. 2 times 10 is 12. So my remainder would be 12. Obviously, it's not a root. Something great, though, that I want to tell you about right now. The remainder theorem. The remainder theorem simply states that given an input, in this case it was an input of 1, the output is equal to the remainder. And I kind of did this on purpose. So first of all, that means the point 112 lies on this line, on this graph. So I'm going to put the point 112, which will be like, say, here. We'll call it 112. I'm just making that up. It's not to scale, right? But the thing is, I knew there was no positive roots. That's what that Descartes' rule of signs will help you do. So when I first started, I could have eliminated these two possibilities right away because I knew I had no positive real roots. Also, look, I know that I have either 3 or 1 negative real roots. Well, that means only one of them could be rational, right? I can't have 3 rational negative roots. So what's nice is when you're using your scrap paper, you could simply erase this stuff right here. And we could just use our whole synthetic division setup again. So let's do that. Let's try negative 1. So I bring the 1 down. Negative 1 times 1 is negative 1. 4 and negative 1 is 3. Negative 1 times 3 is negative 3. 5 plus negative 3 is 2. Negative 1 times 2 is negative 2. 2 and negative 2 is 0. Voila! If the remainder is 0, that means the point negative 1, 0 exists on this graph, and that also means it's a root. Now, you should know from previous lessons that when I have this as the root, let me change to blue so you can see what I'm writing now, that x to the third plus 4x squared plus 5x plus 2 is equal to x plus 1, since my root is negative 1. And then these are my 3 coefficients. So I'm going to be times x squared plus 3x plus 2. And then anytime I'm down to a quadratic, I could simply factor it or use the quadratic formula if I can't factor it. So I'm going to call this x plus 1, x plus 1, x plus 2. And that is the fully factored form of the given polynomial, which is also equal to x plus 1 squared times x plus 2. And that gets me to my final lesson on graphing these polynomials. This x, you could see that my roots are -1 and -2. But Mr. Brew, you told me that we would have 3 roots. We do have 3 roots. -1 actually happens 2 times. My roots are actually -1, -1, and -2. But I don't have to restate the -1, but I do have to remember when I'm graphing that it has a multiplicity of 2. When something has a multiplicity of 2, it touches and turns at the root. Or if I have an even multiplicity, it touches and turns. Whereas if I have an odd multiplicity, it goes through. So I have my roots at -1 and -2. So here's -1 and -2. But again, the multiplicity at -1 is even. So it's going to touch and turn. It's not going to go through the x-axis. Then the other root is at -2, but that's an odd multiplicity, so it goes through. And that would be a rough sketch of your polynomial at that point. So what you really want to remember is how to do synthetic division. Descartes' rule of signs. You're going to have to understand end behavior. You're going to have to recognize the y-intercept. You're going to have to understand the rational roots theorem. And you're going to have to understand multiplicity of roots. All right, and here's the deal. This is like the culmination of all of these lessons. If you kind of understood what I was talking about, but you're having some problems with any of these specific aspects, I want you to tell me. I'll come up with a couple of practice problems and we could always take a step back. This is the end game. This is where you want to be when you're graphing polynomials. And that's why you spend so much time learning long division, Descartes' rule of... All of these are a chapter. All of these are a week or two of school. When you put them all together, you could graph anything you want. And it's really, really nice. So again, if you don't understand any of these 6 subdivisions of graphing polynomials, let us know. Next Wednesday, I'll get some examples where you could just work on that specific skill. All right? Let me get our next problem ready. What's going on, everybody? I had some awesome problems set up, but somebody has written in and sent in a question, and they are most definitely watching the live feed. It's citron de orange or de naranja. I believe we have a South American student asking a question in English, which is great because we are worldwide. All right. So, I hope you didn't ask something too tough. Let's read it together. Unprepared. This is live, guys. I could really fall on my face right here. A tank has 40 liters of water in it at the beginning. Water is pumped into the tank at a rate where f of t is an exponential. 19 is the scale factor, 0.56 is the exponential factor, and t is the exponent. So 19 times 0.56 T, where F of T is measured in liters per hour. Water is being removed from the tank at a rate modeled by G of T is 6 times 1.23 to the T, where G of T is measured in liters per hour as well. What is the maximum amount of water in the tank from the beginning till T equals 5? I have a friend, Hunter was one of my students, and Hunter's dad, Justin, is a friend of mine, and Justin works for the oil rigs over in Houston. And to be honest, he's always asking me questions very similar to this. All right, so let's take a look at this. Water is being pumped into the tank where F of T is equal to 19 times 0.056 to the T. And water is being removed from the tank. G of T, removal, is equal to 6 times 1.23 T to the T. And we start out with 40 liters of water. All right, so we're going to be filling up, we're going to be adding water and taking water away at the same time. Now you could see that this number is always going to be bigger than this number after T is greater than 1. Do you see what I'm saying? So when T equals 0, maybe you guys don't see it the way I do right away. So when T equals 0, that means we're going to be filling up at 19 liters, and we're going to be draining it at 6 liters, right? Because when T equals 0, this number equals 1, because anything to the 0 power equals 1. When T equals 0, this whole thing equals 1. 1 times 6 is 6. So at the moment things are starting, we are going to be adding water. But what happens is, as this gets bigger, this gets smaller, which makes this smaller, which means we're going to be filling we're going to slow the amount of that we're filling. Whereas here, we're going to be, this number as T gets bigger is going to continue to get bigger. So we'll be draining faster and filling slower as time goes on. For example, at T equals 1, we're going to be filling it at 19 times 0.056, which is 1.064. And we're going to be draining at 6 times 1.23, which is 6 times 1.23 is 7.38. So bam, you see that by the time we get to T equals 1, we'll already be draining faster than we're filling. So what we really need to know is, since we're going to be filling faster than draining, and then later be draining faster than we're filling, the point of time where we are filling and draining at the same amount will be the moment that we have the most liquid in the tank. So let's find out when T is equal to each other. What does T equal when the filling and draining are equal to each other? So I'm going to do 19 times 0.056 to the T is equal to 6 times 1.23 to the T. All right? And now we have to solve for T. How am I going to do that? Jeez. Because we have unlike bases, right? So what I'm going to have to do, I can say that 0.056 to the T is equal to 6 over 19, 1.23 to the t. Who sent this in? Naranja, orange, whoever you are. Trying to mess with me, huh? Let's see, what do I want to do next? I'm thinking I want to take the natural log of both sides so I can use the power rule to bring the exponent in as a coefficient. So that's exactly what I'm going to do. Natural log of 0.056 to the t is equal to the natural log of 6 over 19 times 1.23 to the t. Now I'm going to have to use my exponent and logarithm rules. So the ln of 0.056t is equal to the ln of 6 over 19 plus the product rule, the natural log of 1.23 to the t. Then I can bring the exponents out in front with the power rule. So I will have t ln of 0.056. And then I'm going to equals ln of 6 over 19, which is actually ln of 6 minus ln of 19 plus t ln of 1.23. All right, that's why I make you guys memorize these logarithm rules, because they're so important, especially as you get into higher level classes like calculus. Now, I want to bring all the variables to one side and all the constants to the other. So here I have t ln of 0.056 minus t ln of 1.23 equals ln of 6 minus ln of 19. I'm thinking I probably shouldn't have broke those up. We'll see what happens. So this is, I'm going to factor out the t, natural log of 0.056 minus natural log of 1.23 is equal to, and I'm going to do the same step to the left side next, the natural log of 6 over 19. So, I'm just writing out every step. Usually I would do a lot of these steps, 2 steps in one, but I just want to make sure nobody gets lost. So this is actually t, natural log of 0.056 over 1.23 is equal to natural log of 6 over 19. And then finally I divide both sides by this whole thing. So t is equal to the natural log of 6 over 19 over the natural log of 0.056 over 1.23. Don't make this mistake. This is not equal to the natural log of 6 over 19 over 0.056 over 1.23. You cannot do that. That is not good. Are we clear? Good. Very good. And now, I hate to say it, but this is time for the calculator. But you guys have to know how to use a calculator. So I'm going to show you exactly what you got to type in to your scientific calculator to make it work, because you're going to need a lot of parentheses. So what I'm going to type in is parenthesis ln of parenthesis 6 divided by 19 end parenthesis divided by parenthesis ln parenthesis 0.056 divided by 1.23 end parenthesis. All right, guys? A lot of times I would even add extra parentheses, but there's no function here. But a lot of times I would put the whole denominator and the whole denominator, the whole numerator and the whole denominator in parentheses. I didn't need to do it in this particular problem, but always, more parentheses is always better than less parentheses. So, first of all, I already realized, right? We already went through the premise of the problem, and I used my common sense and logic before jumping into the problem. I've already figured out that my answer has to be between 0 and 1. So if I don't get an answer between 0 and 1, I know I'm wrong. All right, so parenthesis, natural log, parenthesis, 6 divided by 19, end parenthesis, divided by, parenthesis, natural log, parenthesis, 0.056 divided by 1.23, end parenthesis. Whew. Got a number between 0 and 1, thankfully. All right, you should be able to see what I typed in. You don't have to study it. You could pause the video later if you want to take a look at it closer. But I typed in exactly what I got. I'm going to round to the nearest thousandth, okay? So this is approximately 0.373. All right, so let's go back to the question. What is the maximum amount of water in the tank from 0 to 5? Well, I know the time. They're asking for the output. Not only the output. See, we're going to start with 40. We're going to add this amount, and we're going to subtract this amount. So, it's going to be 40 is what we started with. And then we're going to add 19.056 to the 0.373. And then I'm going to subtract the amount of water that was draining, which is 19, not 19, which is 6 times 1.23 to the 0.373. And let's go back to our trusty calculator. Again, I'm going to have lots of parentheses. I'm doing 40 plus parenthesis 19 end parenthesis beginning parenthesis 0.056 end parenthesis caret parenthesis 0.373 end parenthesis. So that way my exponent is in a parenthesis minus parenthesis 6 end parenthesis 1.23 end parenthesis caret parenthesis 0.373. And I get, I don't like my answer at all. I got 40.002. But that doesn't sound right to me. It could be right. Let me double check. First of all, 0.056 to the 0.373 is equal to 0.3, let me do that another color, 0.341 is the value of this, times 19 is simply 6.484. So that's how much I've added up to this point. 1.23 to the 0.373 is 1.08. This right here is 1.08 times it by 6 is 6.48. 6.482. So it looks like I was right. So in the beginning, it's slightly going to go greater than 40 before it starts plummeting exponentially. Just like you see the coronavirus plummeting exponentially, just like it rose exponentially. So, yep, the answer will be 40.341. I thought it was going to be a little bit more exciting. That's not much of a difference. So it never goes that much over 40. It goes 341 thousandths over 40 before it starts losing water at a very, very rapid pace. All right, that was a very fun question. It encompassed a lot of stuff. And guys, even if you're not ready for these calculus questions or pre-calculus questions, you can at least see that I'm using the same exponential rules, the same logarithmic rules, the same equation rules, the same function rules as we're learning in ninth, 8th, 7th, and 6th grade. It just builds upon each other. So even if you're just following along, if you understand a couple of parts, that's great. And at least you get to see the application of your lessons when we're doing some calculus problems. All right, let me bring up another question for you guys. All right, guys. So now we have a great question. I think the orange boy was actually a Las Vegas kid. But I have my favorite student from South America with us right now. Somebody I've worked with and I really enjoy working with, Mateo. Mateo, I think, is either in 8th grade or ninth grade, and he's taken algebra in Bolivia. And this is his question. The line with the equation y minus 1 is equal to 5x minus 1. And this equation contains the point 0p. All right? And that's a very straightforward question. The number one thing you need to understand is that, first of all, this is in, you don't need this for this particular question, but you should recognize this is in standard, this is in point slope form. Point slope form is y minus y1 equals mx minus x1. So that means the slope is 5, and it contains the point 1, 1. M equals 5, and there is a point 1, 1 on this graph. Now you could use that to figure this question out. We won't, we will just for fun, but that's not how you should do it. We know we have the point 1, 1, and we know the slope is 5. So we can go up 5 and over 1, which would be 2, 6, and 1, 1. And we could also go down 5, 1, 2, 3, 4, 5, and left 1, which would give me the point 0, negative 4. So obviously P would be negative 4. But that is definitely the long way to do it. So I'm going to show you a better way to do it. This is the line. What this is saying, Mateo, this 0p, is saying that x equals 0 and y equals p. So let's plug 0 into the equation for x and p into the equation for y. So let's rewrite the equation as p minus 1 equals 5 times 0 minus 1. And that's easy enough. First, we'll do inside the parentheses, p minus 1 is equal to 5 times negative 1. 5 times negative 1 is equal to negative 5. In order to isolate the p, we'll have to add 1 to both sides. And we end up with p equals negative 4. And that's just using your simple algebra rules and your simple rules of equations to isolate the p. And notice we get the same number as -4. I hope that helped you, Matteo. I tried to show you some other things. The last way you can realize how to do this is if you realize that the value of x is 0, so p is the y-intercept. Well, what gives us the y-intercept? That would be slope-intercept. Y equals mx plus b, where m is the slope and b is the y-intercept. So once I realize that they're looking for the y-intercept because x is equal to 0 in the ordered pair 0p, I could take my original equation, which is y minus 1 equals 5x minus 1, and I could solve for y, which will give me the rest of the equation. So y minus 1 equals, I got to use the distributive property. 5 times x is 5x. 5 times -1 is -5. Then I have to use the additive property, add 1 to both sides. And I get y equals 5x minus 4. Therefore, the slope is 5, like we figured out earlier. And the y-intercept is -4. So there you go. That's the third time we proved that the y-intercept, or p, is -4. Thanks so much, guys. Please leave your feedback. If I answer one of your questions, please leave a comment letting me know if it helped or if I confused you more. Sometimes, I get so wrapped up in things that I explain it in a way that you guys don't understand because I have skills that some of you might not. Some of you might be taking Algebra 2 and I'm using a pre-calculus skill because I don't even realize that you haven't learned that yet. So there's always a half dozen ways to solve a math problem. I try to show you a couple of different ways because everybody looks at math problems different. If you like the numbers and you like the operations, you're more algebraic. If you like the graphs and you like picturing stuff, you're more geometric. So just understand what you're best at so that way you could always set yourself up to succeed. I'm starting to really enjoy these sessions. I hope you guys are too. Please keep sending in those questions. I like being taken by surprise because if I'm not prepared, I'm dancing without a net or tight roping without a net. Anyway, my name is Mr. Brew. I'm from Infinity the Math Institute. Please subscribe to our YouTube channel so you can always visit our things. Anything you search on, whether it's Instagram or YouTube or Facebook, just type Infinity the Math Institute into the search bar and you should have no problems finding it. You could always email your questions to infinity@themathinstitute.com if you're not with our Facebook or YouTube. You could always give us a call if you'd like to ask us a question about our services and stuff. You can't really ask homework help questions on the phone because it makes it difficult to see it and then paste it. So send your questions. We offer classes both in person and online, so we could do it just like we're doing right now, almost like looking at me and using the bit paper and participating one-on-one or on a small group. But we're also open. We've got 2,400 square feet of beauty, of mathematical craftsmanship. People are doing math all day, every day here at the Math Institute. So please, come join us. Come take the tour. Visit us at themathinstitute.com if you'd like to find out more information. Or, just like us, support us. We really appreciate it. All right? Thank you so much. I appreciate you guys joining us. I see my time is up, so I have to go. I'd stay here all night doing math with you guys. So, Mr. Brew, signing off. You don't get more math problems here.